In this video, we will take a look at our first congruence proof. So we've seen this theorem before, which says that if a, b, c, and d are integers, and m is a positive integer, and if a is congruent to b mod m, meaning that both a and b have the same remainder when you divide them by m. Or another way to write that, remember, is the definition of this congruence means that m will evenly divide a minus b. That's what this means. So if that's true, and if also c is congruent to d mod m, meaning, well, they have the same remainder when divided by m, or I could also write this as m divides c minus d. So if those are both true, then we can sort of add these things together to get a plus c is congruent to b plus d mod m, or subtract them to get the second statement, or multiply them together to get the third statement. It turns out these three things are true. We've seen this theorem before, and we showed how to apply it in an example. And now let's actually prove one of the parts of this. I want to prove the second part. But all the parts have very similar proofs. So let's start this off with some scratch work. Let's think about what it is that I'm given, / I know, / I get to assume is true, / what my assumptions are. Okay, so, well, what I'm told is that these two things, I'm told that a is congruent to b mod m. I'm told that, parentheses mod m. I'm also told, bullet point, that c is congruent to d mod m. All right, and what I want to show in 2 is this. I want to show that bullet point a minus c is congruent to b minus d parentheses mod m. Okay. So, all right. So what I want to do is first give you all some time to try this. So I want to have you all pause the video for 4 minutes to try this. See if you can make progress with the scratch work. If you get done with the scratch work, try to prove it. Pause it in 4, 3, 2, 1, pause it. All right, so hopefully you did that. Hopefully you paused it and tried it. Let's talk about it together now. So remember that a being congruent to b mod m, one of the things that tells us is, well, this is the definition. This means that m evenly divides a minus b. That's one of the things I know because this is saying that a and b have the same remainder when you divide them by m. Okay, well, this one similarly would be saying that m divides c minus d. Okay, well, if m evenly divides a minus b, that's another way of saying that a minus b is a multiple of m. In other words, that a minus b will be equal to m times some integer, and I'll call that k. All right, well, the same thing should be true here. C minus d is a multiple of m, so c minus d should be equal to m times some integer, which I'll call j. I don't want to reuse the same variable because then I would be assuming that they're the same when they might not be. Okay. Well, we've broken down the definitions. Maybe at this point, maybe I'm not sure what to do further with these. Okay, so when that happens, sometimes we can think about what it is that I want to show and try to break this down. So what this means, in fact, for all of these arrows that I have so far, I could have even used if and only ifs because this is a definition. What this statement right here means is that, well, m divides these two things subtracted. So m divides a minus c being subtracted by b minus d. Okay, if I simplify that, this becomes a minus c minus b plus d. To show m divides this, what it would take, this is equivalent to saying, well, m would be equal to, sorry, I got that backwards. That would be saying that this whole thing is a multiple of m. So I would be saying that a minus c minus b plus d, I'm really hoping that this becomes m times some integer. Because if I can show this, well, that's what it means to say that m divides that whole thing. And if that's true, Well, that means A minus C is congruent to B minus D mod M. So I'm doing this. This is a very common strategy in proofs to start to break down what it is that I want to show, to think about, well, what would it take to get me to the thing that I want to show? Because now I think I can see a connection between what it is that I'm given and what it is that I want to show. If I take these two equations and I subtract the equations from each other, I think we'll get this. So I think I have an idea now to connect this all together. Let's start the proof. Let us start the proof. So remember that when I start the proof, I start off by writing down the things that I know, that I get to assume are true. For this problem, that's A is congruent to B and C is congruent to D mod M. That is the stuff I get to assume is true. Okay, then I break down the definitions of what that means. So that first part means, well, M divides A minus B. And the second part means M divides C minus D. Okay, this is where the scratch work comes in handy, because here's where we've done the real work already. Because M divides A minus B, well, that means there exists an integer k such that A minus B equals M times k. Similarly, because M divides C minus D, let me go back here. There also exists an integer j such that let's go to draw mode. C minus D equals M times j. Okay, and now recalling my idea from the scratch work, what if I subtract these equations? So, all right, so subtracting these equations yields the following. So if I subtract the two equations from one another, on the left-hand side, I'll get A minus B minus parentheses C minus D. On the right-hand side, I'll get MK minus MJ. All right, so if I simplify this, this whole thing becomes A minus B minus C plus D equals MK minus MJ. And what I'm going to try to do now is, now I have something that kind of looks like this. Oh, in fact, sorry, let's do one other thing on the right-hand side, which is let's factor out an M. Let's factor out an M. That'll give me M times K minus J. Because now this is looking more like what it is that I needed here. So let's keep breaking it down kind of like I had in these steps. So let's rearrange these terms. Because if I do that, it's the same as A minus C minus parentheses B minus D equals M times K minus J. Okay, so what I have is this whole thing is a multiple of M. Okay, so this means, oh, okay, actually, sorry. I have it written down already in words here. This means that M divides this whole thing. M divides A minus C minus, and then in parentheses, B minus D. I know that because, well, this K minus J is an integer. Since the K minus J is an integer. Okay, so because M divides that whole thing, this thing minus this thing, therefore, what that lets me say is that these two things, A minus C and the B minus D, they are congruent to one another. They are congruent to one another, mod M. Mod M. And that's precisely what I wanted to prove. All right, so we are done.